So I'm doing problem number 31 on 4.2. This one tends to be a little bit harder for people, so I decided to hurry and do a quick video on it. I can't pull it up. I'm still trying to figure out this whole iPad thing, so I can't pull up the actual problem, but I just wrote down the key points. So go to 31 in your textbook, page 283, and you can follow along. Jonathan and Samantha rowed their canoe 26 miles downstream in 2 hours. After a picnic, they row back upstream. After 3 hours, they have only traveled 9 miles. That would be on the way back upstream. And then it says, assuming that the canoe is at a constant rate and the river's current is also constant, find the speed of which they can row in still water. Okay, so first of all, we can tell from the wording of this problem that it's a distance, rate, and time problem. Distance equals rate times time. With distance, rate, and time problems, we always set up two equations, two distance, rate, and time problems. So in this problem, just think about it like here's our water and it's going, and then our canoe also is going. So here's our canoe and it has a rate of we don't know. And then the water also has a rate, which we don't know. So we'll call that y. So when we set up our distance on the way downstream, our distance was 26, which is equal to our rate. Now, on the way downstream, the water is pushing us, so we're going faster. Not only do we have the rate of our boat, but then plus we're going a little bit faster because we have the rate of the water working with us since we're going downstream. So with this one, our distance, rate, and time problem has two elements involved. And then our time was 2 hours. Now, this is where it gets tricky. Sometimes we can set up a second distance, rate, and time problem. And in this one, when we try for the way back upstream, so think about it, guys. Our water's going this way, the water rate, but this time our canoe is going back upstream. So X and Y are working against each other. We obviously know that our distance would be on the way back like 26, but look what happens when we try to set up this. So our rate would be X minus Y, right? Because now not only are we going a certain speed in our canoe, but the water's pushing against us. So we're subtracting out the speed of the water. Now, the problem is we weren't given the time. This 3 hours and 9 miles, that didn't give us the time that it took them for the full trip back. So this is actually giving us what information? Well, think about it. If it takes us 3 hours to go 9 miles, how many miles per hour are we going? So you would do 9 divided by 3 equals 3. Our rate is equal to 3 miles per hour. So with that being the case, we actually know that X minus Y is our speed. And all we know on this one, we don't know the time it took. We don't know that. All we know is that this portion, the X minus Y, we now know this time is equal to a speed of 3 miles per hour. So our second distance, rate, and time problem didn't work, but we were given enough information to set up a second equation because, look here, we now have two equations. There's our first system of equation, and there's our second system of equation. So look again, once again, a lot of people are like, well, isn't the 3 just the same thing as 2 hours? No, this is the total time it took. We don't know the total time it took. All we know on the way back is after 3 hours, they'd only gone 9 miles. Out of the 26, you know what I mean? So with that being the case, our distance, rate, and time problem couldn't be set up. However, we did know the rate was X minus Y, because that is the rate of the boat minus the rate of the water. That would be the rate on the way back, and we know that that was 3 miles an hour. So from here, we could just use substitution. I wonder if I can create a new note. How do I scroll down here? Oh, like that. Okay, perfect. So now I would just take this 26 is equal to X plus Y divided by 2. And times by 2. And I would divide both sides by 2 or times both sides by a half. Because then I have 13 equals X plus Y, which is a little bit prettier, than that other equation. Your other option is to distribute your 2 in and rewrite it like that, but I chose to divide out the 2. Since I did it to both sides of the equation, I'm okay. Then I also have my second system, which is 3 is equal to x minus y. And now there's our system of equations. Look, if we add straight down, we're getting 13, 14, 15, 16 equals 2x. X plus x is 2x. Y minus y is 0. So therefore, x equals 8. Now remember, what was x? That was the speed of our boat. And that would be the speed of our boat in still water. So now if we needed to figure out the rate of the water, think about it, you could just go back right here and plug it in. So we knew that the speed of the water would be 8 minus y equals 3 minus 8. Y equals negative y equals negative 5. Therefore, y equals 5. This is the speed of the water. I think it did just ask on that one the speed of the boat. So that would be the end of that.